Thanks a lot. So my name is Patrick Bamba. I'm a software architect at Attestation Legale. And today I'm going to talk about how we build this translation engine between legacy system and microservices. So basically, it can work between legacy systems and any new services, but I just use microservices so more people would come, basically. So most seriously, I'm going to talk about a little bit who we are and what we do, because you probably haven't heard about us yet. What was the context that motivated us to start this engine, and also how deep dive a little bit into how we actually did it. So basically, we are a B2B social network with customers in different industries like construction and temporary work. And our users, as compared to regular social networks, are really companies. So basically, they register on our website with their legal registration number. And we've been awarded the French Tech Pass a couple of times, and we are from Lyon, France. So I know there are a lot of people from European countries, but this is Paris and this is Lyon, so just so you know where it is. And basically, it's one of the most beautiful cities in Europe. I don't want to offend anyone, but that's just a fact. So basically, what we do, our mission is really to reduce risk in a business relationship and to reduce the administrative burden on those relationships. And how we do that? So as I told you, we are a social network between companies, and those companies have existing work relationship. So for example, let's say that you are this huge client who wants to construct like the convention center. You're going to work with a lot of different suppliers to be able to do that. And the thing is, working with those suppliers, there is some kind of risk that's attached to it, basically because you have to make sure they have the right qualification to work with you, and also because in France and in European countries in general, the law holds you accountable if something bad happens on the construction. So basically what we do is we act as a third party in those relationships by adding a lot of services on top of those relationships. So we allow the suppliers to come to our platform and to register with their documents, and we just validate the documents. We are in contact with third parties to make sure that they are not fake documents. And basically, we can give a summary to the client saying everyone you're working with doesn't have any risk attached, so you can work with them quite easily. So it's interesting for the supplier because once he has registered on our platform, he can just share his documents with everyone he works with. And it's interesting for the client because he can have this nice overview of everyone he works with and what is the risk attached to it. So basically, our context is that, like most of you guys, we started with building these huge monoliths, and it was great at the beginning because we had to bring a lot of value and go fast. But obviously, there's a lot of technical debt that comes with it. And the problem is that depending on your client base and what's your business objective, you cannot just, for example, rewrite the whole monolith and say, OK, I'm going to remove that feature, etc. So the strategy we adopted is to try to have this incremental refactoring by building a lot of services around the monolith and make it shrink over time. So that's just the nerd moment. Who knows here about what this is? Does it ring a bell? So maybe someone can tell us. Exactly. So the Babel fish, just for the story, is from the movie The Hitchhiker Guide to the Galaxy. And it's just this thing that you can put in your ears that's going to translate everything you hear from another language. And basically, that's exactly what we did. So Eric Evans in the book Domain-Driven Design has this to say: the anti-corruption layer is a mechanism that translates conceptual objects and actions from one model and protocol to another. So basically, it's just a translation layer between two bounded contexts, and usually you use it between modern application and legacy system, because as I told you, you don't really want to invest refactoring the monolith. You might want this kind of intermediate layer to be able to translate both ways. So in a concept, that's what it looks like. You have this legacy system, and you have this huge engine, like this black box that does something and translates the calls to the microservices, and it can basically go both ways. So now the question is, why did we use Spark for this problem? Well, there is also this interesting code that says, when it comes to hurdles that comes with interfacing with an external system, the infrastructure layer must provide the means to communicate with another system that might be on a different platform or use different protocols. And also the data types of the other system must be translated into those of your system. So basically, if we sum it up, it's an architecture problem, an infrastructure problem, and you have to handle data types, protocols, and different models. And what's really cool about Spark is that out of the box, it provides you with this architecture pattern. So basically, as a developer, you just have to write your code thinking that it just runs on the driver. And the guarantees that comes with this distributed framework are just abstracted away. So you don't have to reason about that. You can just write your code, and out of the box, Spark provides you with an architecture for guarantees like fault tolerance and availability, things like that. Also, when it comes to infrastructure, so basically you have different ways to run your code once you know how to do it. You can do it with a standalone cluster on Apache Mesos, on Yarn, and you also have those services, where you can, register and just like ask them to help you to run your code, and that's really really interesting when it comes to what's the ROI of using Apache Spark. Of course, as I told you before, there are types of data to take account and protocols, and basically with Spark you have those built-in sources, Parquet files, JSON, Hive, and different open source connectors, which out of the box allows you to handle the different protocols and data types, and you don't have to code this extra logic in your system. So when it comes to the model, historically you had on one side the RDD and a data frame, and without going too much into detail, what it allowed you is that with the RDD you had like this type safety, and the code was really expressive because you could use like your regular business model. On the data frame you have like this optimization, so your code could run faster, and basically you have the choice to choose between the two. And now with data sets you have both, so you basically just can use your business logic, and Spark doesn't force you to adapt another model to handle your business logic. And finally, with Spark you have like this unification of batch and streaming. And because we wanted to adopt an event-driven architecture where basically your legacy system is going to publish an event and it's going to be translated in real time, that was really a definite game changer for us in the reason why we wanted to adopt Spark, and also the reliability that I'm going to talk a little bit further. So basically, if you want to just to have a quick overview of what an ITAC correlation layer looks like, so you have this interface that's just going to receive, for example, an event or a call. You have the adapter that's going to use several translators that are going to translate your model to another model, and this facade which is going to expose the transform model. So basically, with a quick example, first I'm going to define those different business entities. So you get your legacy documents and different other models. And the second thing that's important is the translation step, which is basically a model that helps you to hold what is the state of the translation after a definite, a specific step. And so if you want to just see how it works, basically your translator has a method that's going to take a data set of a translation step and just going to transform it and put out another data set. So for example, I have a translator that's going to be called an insurance resolver, which role is going to add some information on the legacy model by adding some insurance information. So when you look at your adapter, so basically you might have a method that's called initialize that is going to take a data frame as an input and going to initialize with the very first step. And then you have the adapt method, which is going to take a sequence of translators and basically compose the translate function so you can create a pipeline. So your adapter takes, the very first data set, some translators, it's just going to run the transformation with that. So now, what if you want to add, for example, external information while you're translating? You want to make some data enrichment. For example, you have some information in Parquet or Elasticsearch, and you just want to join, your legacy model with that external information. So then you can basically write some kind of repository which is going to write in Parquet, take, an insurance, and then your resolver, your translator, is just going to join your existing step and add this insurance information. So here, for example, with the join with, I'm doing a left join because the insurance might not be available, and I'm just going to add an error if it's not available, or I'm going to update my step if it is. If you remember, we were trying to move code, not code, but like data from our legacy system to our microservices. So the first step is going to be to do this batch, migration of data from our database in our legacy system to the microservice. And we're going to use, obviously, Spark for that, but I'm not going into detail with that. And let's say, for example, that for the streaming use case, you want to write the data from the legacy system into Redis, and then you're going to consume this data with Spark, and then send a call to a microservice via HTTP. So basically, structured streaming gives you an interface for that. So you have out-of-the-box sources like, for example, 5 Kafka Kinesis, where Spark just can, with some simple configuration, allows you to read from that. But you can also write your custom source just by respecting a given interface. And that interface enforces that you must be, as a source, able to replay some sequence of data. And that allows you to provide some end-to-end exactly once guarantees. And that contract is really more simple, to reason about than distream receivers. And I don't know if you remember, but starting, I think it was Spark 1.4, you had the ability to use Kafka and have like this direct approach. And I mean that's basically the same approach. Spark is just going to pull data from your source and run it as a batch, and then produce the output. So here I just wrote a custom Redis source. It might not be optimized, but it was just as an illustration. And so basically, you have this module that is going to be responsible for running batches. And the first thing it's going to do is going to call the getOffsets method, which is a method that's supposed to produce what's the biggest offset in the source that Spark can query. So here I'm using the Redis connector, and the data is stored in a set where, for example, an element can be a JSON string of the data, and the score is going to be incremental ID, for example. So in the getOffset method, I'm just going to find what's the biggest offset in the set, and just going to send that. And if there's no data, I'm just going to produce none. And then once there is a new offset, Spark is going to call the getBatch method, and the getBatch method is basically what Spark does when it wants to handle a particular batch of data. So it's going to give you a start position and an end position, depending on the offsets that you provided in getOffset. And here it's just going to build a data frame in that method, so Spark can process it. And finally, you have the commit method, where once the batch is processed, Spark is going to call that method. And then you have the source provider, and that just allows you to register a particular source so we can use it later, as we're going to see in other example. So basically, the short name is the same thing that you see when you're using structured streaming and you say, for example, Kafka. That's the short name of the Kafka source. So we saw the interface, and now when it comes to the facade, the module that's going to be responsible for pushing the data. Spark gives you out of the box a certain number of things. for example, file and console, but it also allows you through the for each writer interface the ability to write your own writer. And there are different output modes available. I'm not going to go into detail, but basically you just you can know if you want to output the whole data, just the data that was just produced, or just the data that was modified. So basically, if you use for each writer, you can. Here I'm just like sending a call to some fake address, an HTTP call. So I'm going to initialize the request. I mean the request object in the open method, and then you're going to produce a Boolean that says true or false, and that's what's going to be used to know whether you need to process a particular batch or not. So then the process is going to be called on every record of your batch. And then if you have, like, for example, some request cleaning to do, you can do it in the close method. So basically, when it comes to Spark streaming and the unification of batch and streaming, streaming just represents an unbounded data frame. So I mean, I just took this really great illustration from the Spark documentation, but it's really simple to reason with because you don't really have to have a slightly different, interface to handle between streaming and batch. It's exactly the same one, but the thing is, so far, the interface is the same, but the methods that are allowed in batch and streaming might be slightly different. So, for example, if you're using the accept method on a streaming data frame, then you might get analysis exception when you run it. And some operation might be slightly different whether you use a regular data frame or a streaming data frame. But what's really important is that it simplifies testing. So basically, before you had to write a test for streaming and a test for batch. And even if you could reuse the code, you still had some boilerplate code that could be slightly different between the two. And now it's basically the same code. So what's below the load method on the top and on the bottom is exactly the same code. So here on the top, I'm just reading from like some JDBC database. And on the bottom, I'm just using the source provider that we wrote earlier to query data from Redis. And the rest of the code is exactly the same. So even from a developer's point of view, it's really simple, to make some nice abstraction in your code and don't have to juggle with streaming and data frame. So that's an example of a test. So basically, I'm going to mock the different repositories that holds the data that I'm going to use to enrich data. And then I'm just going to assert that the data that goes through my adapter is exactly the data that I'm expected. And that code works for streaming and batch. So even testing is really simplified. So general takeaways about our experience with streaming. It's really important to use checkpointing to recover from failure. I don't know if you remember, but I told you that Spark asks you for the offset when querying the source. And actually, Spark also uses checkpointing to save the offsets. So that's something that's used for that. So we can use it later to recover from failure. The streaming tab has disappeared because the devstream aren't used anymore, but for that use case. But you can use the streaming query listener to have a lot of information about how the streaming query goes, and so that's really interesting to use. And basically, if you want to be able to handle the flow and the size of your batch, you have like different options. For example, using Kafka, you have the max offset per partition, which allows you to put a limit on the size of the data that you want to handle in every batch. So that's nice if you want to make sure that because you have a burst of data, you're not sure how the system is going to handle it. So you can put like this limit on it, and the trigger is going to allow you to define how often you want to run a particular treatment on a batch. And when you're working with aggregation, you can use watermarking that was really well explained in other talks to drop some old records. So that was just a slide about watermarking. So as a conclusion, I just want to say that the story was about showing you how there are different use cases to use Apache Spark. Our use case was a use case of software migration, and it happened to be a really good fit to implement that pattern. Structured streaming is really young, it's starting, so I'm excited because I've read that there are going to be a lot more sources and sinks, and maybe tooling for monitoring, and maybe a lot more information on how to handle end-to-end guarantees, especially when you're writing your own writer. And it's really great that the line between batch and streaming is thinning, because it just makes the life for the developers way more easier. So basically, that's just like a bunch of sources, but I think the documentation and the code is a great way to know how structured streaming works. When it comes to source and seeks, you have some simple source and seeks, like the file ones, where you can just, by reading, understand how they work, and that really helps to implement your own source and seek. You have a YesEC blog about structured streaming, which is just great about to know how it works and exactly what happens when. The Databricks blog is really great to have a lot of resources about that. And for the testing base, personally, that's what we are using, but there are a lot of other great libraries to work with that. So just a quick note saying that we are hiring. If you I've convinced you about our use case and you want to join us. And basically, you can find the code for this little demo about on my GitHub, and you can find me on LinkedIn. Thanks a lot for your attention.
Awesome. Thanks so much. Great talk. So we have a couple more minutes here. So if you have any questions, step up. I think that this is a really good opportunity for sort of talking to someone that's gone through a lot of the process of, one, deconstructing the monolith, which is something that probably many people will have to go through, and then also being able to migrate from Spark streaming to structured streaming, and what that process is really like, and maybe where those edge cases are. So yeah, if anybody has any questions, feel free to step up.
I'm available after.
Yeah. Sorry, it's probably not really about Spark, but it's more about deconstructing the monolith. So you mentioned a microservices architecture.
Yeah.
How did you break up? Did you find some way of splitting the application into strands, or how did you, or did you? I mean, how did you split that kind of functionality?
Well, the business context really helped for that. For example, you have some context that's going to be some business logic that's going to handle, construction sides, and some others are going to handle relationships. So basically, we've just taken it like context by context. For example, when it comes to the streaming, we have an adapter for handling relationship transformation, an adapter for handling document transformation, etc. So we've taken it like business logic by business logic. That's how we've disconstructed the monolith.
And are they autonomous? So do the various teams in that have some level of autonomy, or are they governed more or less by the great diagram that you had there, with the in terms of the repository patterns and the adapters and whatever else in there? I mean, how much autonomy is there?
Well, we've built obviously some interface about the adapter. For example, with the translator, you had these traits, and that basically says what a translator is supposed to do. But how to implement it really depends on what logic you're handling. So there is definitely a lot of autonomy to add a lot of logic there. So yeah, we just have a lot of interface, but then people do whatever they feel that's necessary to handle the problem.
Thank you.
No problem.
Any other questions?
Well, thanks a lot, guys.
Yeah. All right. Let's give them another hand, and people can grab some coffee, stuff like that.